Yeah, I'm sorry. So this technology is basically an ultrasonic technology that sends several different types of waveforms down the pipe in long distances. This particular line, I don't know what you're seeing here, but we have the capability with these to go up to 150 foot in both directions and look for anomalies, corrosion, weld defects, some things like that. So what they're doing here, this ring, do you guys have a ring that is off the pipe?
It's on.
Yeah, okay. So this ring, let me just grab it all. This particular ring is these transducers, okay, they generate sound in the pipe. Some vibrations at a very low frequency, and they literally flood the pipe wall thickness with sound. There's a couple different forms of the sound wave. There's a torsional sound that actually spirals down the pipe. There's a compressional wave that goes down the pipe, and then there's some others. There's a flexural wave that is, I don't even know how to explain that.
It's a torsional wave that actually the entire group of those shift back and forth.
Okay.
And so if it comes across any features in the line, it'll be able to stay on shift.
Perfect. So all of these wrapped around the pipe, these are energized. You're actually looking at examining the pipe wall thickness for corrosion, external or internal, for up to 150 feet in both directions.
So see, why these guys like Dan and Swash and Rick to follow this stuff along? In the past, if you wanted to work underneath this ground, we'd have to dig the ground.
Yeah, we'd have to dig that casing up and then cut the casing, take it off just to get to the pipe, then strip the insulation, so on and so forth. In the wintertime, it's tough to do.
Well, it's very expensive, very
Yeah,
inefficient.
even in the summertime.
And you can imagine now, with this we've been doing a number of new. The challenge is here is how do you actually, with 1,100 miles that you need to retain this? How do you? If we actually using the old technology, we got that place for we were actually, I think we estimated at one point we would have to build 2,200 feet.
Use every bed.
So we'd have to build another 2,200 million plant back there to do that.
Just for
We realized this was impossible. We would never ever be able to do it. So what it really was, we had to find new technology. Otherwise, we weren't going to be able to meet the expectation. So what they can do with something like this, they strip off the pipe here. They can now look 150 feet either way. They can look underneath a road crossing or a caribou crossing. And how long does this take you to do?
Something like this, a large diameter line with sticker, it's a little bit longer, but at the very most, the line has to take scan. So instead of time, it's going to cut out.
So you can imagine in previous you'd be talking about days, if not weeks worth of work just to get to where you could do the test. And they can do it.
You have a crew
This technology, you don't need someone on the other end receiving it.
It sends and receives. Since there's the two white pieces on those modules go in either direction and they alternate and they send the signals out and it sends out and it listens for a few microseconds and receives sort of like a sonar.
You basically just pump air into this right now.
Yeah, this is an inflated.
Those things run like
You
that.
pump it up and actually squeeze it onto the pipe, and then you generate the sound. Actually, PHMSA has an 18-point guideline that we work to. We develop all of our procedures to an 18-point guideline that PHMSA has published, and that's how we do this work.
So you guys going to run a test? We're going to get to watch it?
Actually, it takes quite a while because it's so thick. It's going to take quite a while to run the test. But we have run the test, and the data's here so that you can see it. And I'll let you, Chris, go ahead and just.
And actually, if they were running a test, you wouldn't actually see anything. You'd just be looking
Actually,
at it.
no. All we'd be doing is sitting, waiting for the energy to come back and group it up. But
Yeah, this is our main screen, and I've got it set up to actually run the test, and I can stop it, but I would check through here, you check how well each one of the modules is actually seated on the pipe, because it makes a difference. And then you set what range that you want to look for, and different parameters with, this is a 28-inch line, so you would set all these different things in. And then it's just as easy as hitting the collect button. And it checks the capacitance of every one of the modules to make sure that's in working order. This is the main signal processor unit that comes out and sends the signal to the ring and then also processes it. And right now it's actually taking the scan. And each one of these green lines represents one of those transducer modules that's sending the sound out. and receiving. And generally, if the green lines mean that it's good, and if the red lines come up down there above it, it means you have a problem with one of the transducers. So as the test is being made, we can see whether or not it's going to be good or not.
How do you tell? How do you measure an anomaly?
So you go to the results screen.
Yeah. Now, just we did this before you all had shown up, and I'll go back to that previous file. And that's this was the test we just ran about half an hour ago. And we go to an analysis screen, and this brings up. You can add the features descriptively. This up here, this bar represents the case itself, where it has a little sleeve around it, and this is an insulated line even through that casing. So that it shows up on there, and then we just add what it is. And the first thing it sees as it's going into the case is it sees this right here, which is a weld. So looks like about 5 feet or so into that casing, we know that there's a weld by the way that that signal is reacting. And farther in, if there was any kind of major corrosion problems, it's not as simple as just saying you would see something on there, because you have to size it and things like that. But if there was a major problem inside there, we would see some sort of indication. And it doesn't just scan at one single frequency, it scans at several different frequencies at once. So we can shift from, it's called a frequency regime, and you can go from low frequencies to high frequencies because it sees the features differently. So at high frequencies, because the bandwidth is smaller, the frequency is smaller, any small feature becomes more pronounced. And then at lower frequencies, you see more of a general area.
At what I guess point do you measure something as being something that needs attention?
Well, that's actually called, we have a line that we set based on the welds, because every line that we test generally is going to have a weld in it. And we know what the response is going to be from a circumferential weld.
Right.
So that is our baseline for what we size everything else to. And since this is a weld here, we set this dotted line, it's called a DAC line, a distance amplitude correction, and we set a line to that, saying that that is a weld. And this blue line down here that comes up says that anything that comes up above that blue line is a certain percentage of what a weld would send back, and that's what we would check out a little bit further.
So basically what we do is we take the height of that weld, we use that as our calibration, if you will, and we adjust, and then we take a percentage of, and that line is actually a percentage of all the sound that was sent out, okay? And then we take a percentage of that again and look at anything above that. What it does is it basically comes down to, we want to see 1% cross-sectional area loss or better. And to do that, we have to have that blue line as low as possible. We set that at about a 3 to 4% level, 3% of the reflected energy from the weld cut. And that equates to about 1% cross-sectional area. And if you take that equation and compare that to a smart pig, it's identical to what smart pig industry standards say that they will find routinely.
There we have it. See anything?
I'm sorry?
There's some difference between the blue and the red.
It's differences, but the red doesn't necessarily mean bad. It
Once
just
you get
means
out
different.
here, this is repetitive.
Yeah, because the line is insulated, it actually dampens the signal going through, so it attenuates as it goes through. So on this one, we only are going to get to about here, and I haven't really fine-tuned it like I could, but only about halfway through the crossing on this side, because it's a really thick, thick line. No. And what we would do,
so what we do, we establish based on the level from those welds, we can establish how far through that casing we can see. We can either do it from one side and get all the way through because we can see drift flow beyond it, or we have to go to the other side and then strip and actually if we don't see that overlap, take credit for that sound. And most everything we're doing, we should get 3 to 5 feet overlap.
and when we take a scan from both sides, when you see everything from one direction, then you see the exact same thing from the other direction. It's a really good way to do it.
What is the distance, say this weld is from where you're?
This green line represents the actual where that ring is placed on the pipe. So the distance there is just under, say, I can tell you exactly within within a few millimeters. It's 39.075 feet.
39 foot from that ring in that casing is a girth weld, which those are 40-foot joints, and they set in
Right next
or
to it.
less than a foot from that girth weld.
So when you get out to this point, that's when it's beyond the level that you can really see things
On this scan.
So what they do, let's say now they saw some problem in this scan, because they know where it is. We then come in and if we found the problem there, that an anomaly that looked like we had a potential corrosion issue, which we have a ranking process. So
Sure.
We then go dig it up. And it would strip the insulation off the pipe, and we'd go and use something like UT or something
Right.
else. It would also physically lay our eyes on it, so we'd buff the pipe down, we'd look at it, we'd get a fine-tuned rating. Depending on how bad it was, if it was bad enough that required remediation, then we might have to put a clamp on it, or in some cases we would replace a section of the pipe. In other cases, it was within reasonable operating standards, we just coat the pipe so it can never corrode there, and re-insulate it.
Which is what we're going to see at the next time.
And in fact, what
Internal, external, as you can tell, that's what the wall thing, right?
that's why you have to go back in
Right.
when you see an anomaly. Then we have to go. But the problem you had before is you had to dig it up just to this.
Just recently have we been able to tell now where it is around the pipe, so we can pinpoint it around the pipe. We still haven't gotten to the point. This technology hasn't gotten to the point where we can say that's internal, that's external. Close, but we're not there yet.
And then how long have we been applying this?
We started applying this in August, September timeframe last year on our NGL line. We've taken it from there. We actually developed this procedure up here with the gentleman that invented this. We had him up here for almost 6 weeks, and he developed our procedures for us for our case crossings and all of our concrete anchors. So we're able to look under the concrete now and stick the pipe into our concrete anchor and find some corroded pipe there, busted the concrete off, and it was almost so you could lay it on top of each other. It could work very well.
This technology. And this is once again, this is what we call. I think this is an LDF here. Isn't it?
Yeah, this is large diameter.
So this is one of these lines coming from a well pad with oil, water, and gas.
This particular
is a line
line.
regulated by ABA.
This particular line is all the produced water from GC1 is actually sent over here to GC2 to help with their shortage of produced water, and then goes out to LPAD and is pumped downhill. So we should move on.
Yep.
Thanks,
guys.
Thank you.
Thanks, gentlemen. Great job.
Tony Brock, technical director of the CIC guys, works for me. Hey, Jerry. Really neat job.
Thank you.
Works okay?
Yeah, it works really good.
Keeping you busy?
Oh yeah.
We're trying to get as much done before winter sets in as we can, you know.
Yeah. Well, I've only been here since mid-June, on and off, so I haven't seen the winter yet. So I'm looking forward to it.
Hey, it's not too bad. You know, they try to look after you as best you can. But hey, look, appreciate that today.
Thank you.
Cheers.